Hello everyone, thank you for my talk. Not for the lunch, it's lunchtime. Uh, Today we will share about some research about the attacking Microsoft.NET framework through the CLR, and let's introduce ourselves. This is my Jason Shikang. He's a security researcher from the 360 team, and he's the lead author of this paper. And this is his email address. And I'm Red Ring, Yu Hong. I'm also from the 360 team. Uh, and I also gave some talk on hacking the box last year, and HitCon, RexCon, XConf, Syscan 360, and I'm also the member of Light for Freedom. And this is my website. I often give some papers on my, submit some paper on my website. And this is our team, the 360 cert. Our team is created May last year. We are a young team and a powerful team. We focus on some emergency for the cyberspace upstream, and we also focus on the malware analyzing, threat hunting, and botnet tracking. And this is our team website. Okay, this agenda. First, we will introduce some basic of .NET framework and CLR. The core point is MSIL code and some points we're interested in as a possible weakness. And then we will review some security issues for CLR before. And we can learn from the history study. We will introduce the VSTO weakness and show some effect about the VSTO attack in the real world. Last but least, we will introduce the fuzzy mode about CLR and how can we find more bugs from CLR security research. Okay, first, the .NET framework and CLR. This is my turn. First, the .NET framework provides a runtime environment called the Common Language Runtime, which runs the code and provides service that makes the development process easier. And compilers and tools expose the common language runtime's functionality and enable you to write code to benefit from this managed execution environment. For example, just like you can translate one language to another language. This is managed code and metadata. In the translation, the information is called the metadata to help the complements to interact seamlessly. And when you write a code using a high-level language on top of the .NET, such as C#, VB, and F#, such as these languages, in the compiler, we'll create an intermediate language. In the intermediate language, which calls the MSIL. It is Microsoft Intermediate Language, MSIL. Yep. And this is a basic context about the metadata. Metadata is stored in one section of the .NET Framework PE file, and another section is for the MSIL. So the first section is for metadata. Another section is for MSIL. And the metadata portion to the file contains a series of table and help data structures. The MSIL also include the metadata tokens. The metadata tokens reference the metadata portion of the PE file. For example, you might encounter metadata tokens when you use MSIL decompiler, such as a tool named the LLDAMS. This is a decompiler tool. When you use the decompiler tool, you will see the MSIL, such as just like the red image. This is a IL code. And after compiling, the type information is saved as metadata in PE format, in PE file. .NET is based on object oriented, so there's some important object in this. The image shows us all the object, but I think as a researcher we focus on some important. We're interested in some object in the left list. First, the def table. Def table describes the type and member information defined in the source code. And the second, ref table. Ref table refers elements can be other modulars of the same assembly or the different assemblies. And the second, pointer. My pointer is just a pointer. And the last, help. The help is a common language in the is a common knowledge in the security, just as the help. Okay. And for metadata tokens, in a whole metadata tokens, each row of each metadata table is defined is identified the MSI portion of the PE file by the metadata tokens. The metadata tokens is include just include the 4 bytes. The top bytes defines the modular and tab refer, and the other bytes define the rows in the metadata table that the programming animates the being the first byte is in the defines the modular and the type refer, and the others define the method. If you write the method in C# or as a high-level language, in the compiling, the P file, the other rows will fall in the metadata token and MSIL portion, and this is the other rows. For example, you can see the left image, the address. For example, the ZX 0x06000, and the top byte, the 0x06, it's include the metadata method def method. It's include the metadata method, and the lower bytes, the other bytes, tells the common language runtime to look in the false rows and to describe the method definitions. This is first rows and the other rows. in the metadata token. And it's a magic code. As I said before, when we write a program in .NET high-level language, the compiler will translate this code into immediate language. This immediate language is MSIL code. And you can see the exam in the image. This is the exam MSIL code of the C hello HITB. And we can see the reverse result. This is the reverse result for the IL code. So the next page, you know, the operating system and the runtime environment provide some process to load the program. But in the .NET, it includes the hosting program and the non-hosting program. Maybe translate it in the English is hosting program and non-hosting program, and not just one process load only one program. One process can load many program. The many program is in the application domain. Application domains provide a security protection for the whole process. And in this loading process, the manager is CLR. The CLR manages the whole process in the loading. And as I said, the program includes the hosting program and the non-hosting program. In order to manage the application domain, the CLR will manage it. This process is called CLR hosting. So this is the primer of the .NET and CLR. Sorry for my rubbish spoken English. And if you can understand clearly of my accent, you can break me in any time, okay? Okay, the next part is my colleague Shikang's job. And this is his first time in the conference to share the research in English. So, okay, this is his turn.
Hello, everyone. I'm Shikang, and I will continue this part. In China, we have a slang, 温故而知新. It means that we can know when we will reveal the previous knowledge. It is same for the researcher. When we want to find a new bug, we usually reveal the old. There are three points that a typical MSR injection, UAC bypassing, and SQL will CLR. For MSR injection, we have three methods to do. In order to injection our code what we want. First, we will forget all the process of the R code completing and execution. As Radrin said before, R code is coming by higher level language took over by CLR, and CLR will load it and translate it into the machine language. So we'll just need to control the CLR loading or higher level language translating. The first and second both belong to head modifier. While we studying, we find the CLR provide a method to modify queries as simply and a new one type or message into loaded assembly. It is called profiling. So we'll have the software. Plan A is a hooking complete message as the program enter, and replace our code what we want to be executed by the really complete message counting. Because complete message execution because its object is a message. So we will know where is while we inject. This is an example for finding injection message, and then combine it. CLR will call common message. We can replace the common message through is hook. And now we need to replace our code before the complete message called and restore the program execution status. Also, we can make for minimal threads for different .NET version. This code is not unified. So methodiscal reset provides is well to modify, and we can find the reset address through PDB of the sample server. And then we'll need to add our code into complete method. It is in order to reset method disco to projected. There will be complete where fashion calling. However, there is a limit in this plan. If someone message would not be called, because when we can locate the message name through get message fashion. This is possible by Ferical machine. Compared to Plan A, Ferical use a technology called template to jump to the special technical method. Therefore, the flexibility of the Plan B is greatly improved. It's physical use template is install template at the beginning of the code, and use template is defined dynamical method that we have the special method script, and last end represent assembly.
In the last page, the Plan B is proposed by the Fracum magazine, and this solves the problem in the Plan A we doesn't solve. Just he can install trampoline in the beginning of the code, so the attacker can call the dynamic dynamic function. This is more this plan B is better than Plan A. The plan A is have some limit, so the Plan A can't call the dynamic method. Okay.
And the last plan we find is where we write the status. When there are lots of classes and execution, it could be increased by profiling API and modify our code before just completing. Actually, the itself insertion of profiling injection is set up profiler DEL. It is connected to CLR by acquire profiler callback and acquire profiler info. And last, user can insert a customized function into our code before GRT comping. First, we need to get the slot of injection position. This is GRT completion started, and we need to pass two parameter function ID and flag block. And then we need to get a function body. This first function is get R function body. This there are two parameter model ID and message ID, and it's will render to a pointers. The second function is set R code set R function body. In the first function is in the order to get the structure of the ARM function, and the second is go to modify the ARM function. And because there is some security protection in CLR via GRT completion, we need to flag some pointers in the work. First is head. Head is has a code size and set header. Second is program status. It has static have parameter and renter address. When a manager process application or services starts, it allows the computing language return. When the CLR is ring, he is should the environment variable to decide whether the process should connect to profiler. Car able profiling and the car profiler. If the car able profiler providing change path, the CLR connects the profiler. That is class ID or program ID, which must have been surrendered its provider in the registry. The profiler CLR application, you must set the core able profiling and core able core profiler environment variable before you run the application. You must also make sure this profiler DEL is registered. And there is a compare of the plan in the following table. We can see that all of three ways to inject. Plan B is the best choice. It can be suitable in most series and invoke any function you want to. Actually, we can do something interesting using MSR injection. For example, CLR files, UAC bypassing, and more. There is a case. It is a difference between .NET and COM real-time. .NET doesn't provide process elevated production via class ID. .NET framework can be made to load profiling DEL or component DEL via user difference environment variable and class ID registry enters. It can be explored to bypass using bypass UAC in in different setting on Windows 7 to 10.
In my mind, Microsoft doesn't consider the UAC bypassing is a vulnerability, but we also give this example of the POC to show the MSIL injection to do the UAC bypass. We have a simple demo video in the next page. Okay.
In order to make a .NET application load on RDL, we need to set a environment variable. In the really attack, we just need to find an executable that is until elevated and use .NET CLR to load our figure profile DL. And MSC is great to be the as an example. In the case, we use JP edit MMC, not only MMC, and there have other usable ones, and we will show the other in the demo video. Let's pick.
Okay. And this is a simple video. First, this is the POC. We show the last page. Just write to the PowerShell script, and to run it. It is in order to change the environment. And you can see we run the who am I. The who am I is a system command, so the system will not alert security alert. So this is a simple video to show the UAC bypassing was profiling inject, but Microsoft doesn't think the UAC bypass is a vulnerability. But this is common in the real world. You do some pen test. Yep.
And next part, our hacker no SQL injection, but less no attacking SQL server will CLR. Through this attack surface as extends many years. Here is a basic payload. The SQL Server injection has three parts. First one is create a SQL Server project via Visual Studio, and create a procedure, and last is SQL Server loading 那个 DL. And let's take a look at the payload again. The first one is create as assembly and try to load the DL. There will two ways to load DL in SQL Server. There pass A and through fail with hex decode. Obviously, load fail with hex decode is better. Next, set up payload through Visual Studio. Just write a normal C# code and complete it into a SQL Server project. And here we'll get the SQL Server project, and we need to hex decode. It's script has procedure name is in Visual Studio project is class name, and this as assembly name is assembly name is fashion name. Last is execute the assembly name.
And this is the result he execute as MS Circle. He means in this attack, Circle server consider the implicitly as a function name. So you just need to execute the function name, and the Circle server will execution the del what you want.
Also, there are so in this attack, it's still easy to export. CLR servers must be able on Circle server. It's not defined. However, we can turn on it use one Circle query. Use SP configure function is to enable it. And its second one is and the second one is to slow the trust program. Their account must have execution permission. We could do evaluation of the elevation of privilege by DBA to slow it.
And in the real world pen testing, this is very common that XP CMD shell is can be restored, or your Circle account is low level, and you can use this method this way to to do execution, not through the XP CMD shell, and you can do some elevator of the privilege to do the to lead to the DBA. Okay, this is the two ways in this attack you can do. And we also make a simple video. This is the normal project. You can write the normal C sharper. And this is server has Circle injection vulnerability. And this is load the del. You can see the Circle server have loaded the del, and we will reverse a shell. We want to reverse a shell. Okay, the shell is reversed. The IP address and the recent IP address. Maybe we will write a better automate tools, such as Circle map temper for just submit our temper to the Circle map project. And okay, sorry for our poor English. Maybe we'll suggest Dylan. Dylan is not here. Maybe we'll suggest Dylan to provide the translator in the future. It is better to sharing the research, maybe. Okay. The last part is mine. Here I will introduce some interesting research. By restarting from the history. first the VSTO, VSTO attack surface. VSTO, VSTO is a set of development tools by Visual Studio. And Visual Studio will provide this VSTO to create an add-in. This add-in can be can call the CLR to expose their function, and this allows extensions to the Office applications to be written in a CLI compliant language. So you can just think it a normal documentation become a programming documentation. The documentation can execute the system code. Yep. Okay, let's take a look. Sorry, this is a Chinese version. We can see the project VSTO. VSTO can create Excel, InfoPass, Outlook, PowerPoint, Visual, and Word. All of these support the add-in, just the extension. Not only the extension, not only the add-in, but also the Excel and Word. Excel can create a workbook. Word can create a document. So you can choose the VSTO to create a single documentation file. And also Excel and Word support the template. That means the template and extension, just like the add-in, will load while you open the Office application. If you open the application, the add-in and the template will load. Yep. So as a hacker, you can say you can choose this method to do a backdoor. Yep. When we create this project, we just need to write a normal C# code in the document namespace. Here I read the hello to using the message box to output hello, and but there's two things we need to solve. The first, recruit. Because the Office application will check the if this documentation is legal or illegal. So when you first to open the documentation, it will take this alert. And this is the first one. And the second one, you will see when you build a job and after compiling, there's more manning and mass the file. It's not else the documentation single file. There's a manning file. So this is two problem we want to solve, because no one will to click with this manning and mass file. Okay, so in order to solve this, we will understand the why the Office application will alert, why there are many mass file. We will understand this. The first one, the Office application when the first opening, the office will to search a special value in the registry. If the registry has the tag has a special value, the special value is load to is in order to load the add-in or load the template. So the first time you open, it will search it. If it search it, okay, check pass, and this alert is doesn't is doesn't this alert is missing. Okay, but if check false, there's this alert. So this is the first one, and the second one, the many mass file. This is called the additional file. The additional file must be here, but we have some trick to hiding this. To use this command to hide the additional file. So in the whole research, we understand the first one and the second one. After that, we have some attacking surface in the real world, and we try to do this and show the effect of this attack. So we have two attacking surface. The first one is documentation fission, and the second is to do a backdoor. To do the backdoor is easy to understand. Just make add-in extension or template. Just you control someone's PC, you can do this one. This one to do your backdoor. And here we will introduce the first one. The first one is more interesting. We count the documentation fission we cached by our EK landing. We have a system. The system can land some exploit kit, and our system has a sandbox. We catch the documentation fission in a month. The result, sorry, the image I have not changed to the English version. The result is in the documentation fission, the macro is nearby the 60%, and the vulnerability exploit nearby the 36%, and use some future and others nearby the 5%. What is future? Just like the DDE, you know, DDE and OLE. The DDE execution is popular last year, and Microsoft provides some solution for this later. Okay, but this is just the result we catch, and we analyze it. We find the we find something that macro is not the most highest successful method. Macro is not the highest successful method, and the exploit, the vulnerabilities exploit, it's just because there are so many pieces install the antivirus, and the antivirus will protect the vulnerabilities protection. But the latest, the 5% features, OLE and DDE, is the easiest to exploit in the real world. So we think why? We think we think the reason is the DD, for example, the DDE. The DDE first is first one is not a vulnerability, is a feature, and so some antivirus will not product with the DDE, and the users just say no DDE. What is DDE? I don't know. I'm just a user. Okay, you want me click OK? Okay, click OK. Okay, I can see the documentations. So that's why I that's why I think this is the most possible in the result. And then in order to research clearly, we put some phishing attack in a real world. Just comparing with some the social engineering attack. We create some phishing documentations named PUBG, the game, a PUBG map hacker, or some the best hot girl, just name that, and some the file name and we create the code just collect some information in queries such as the host name and IP. We do not do some evil in the user's PC. Just collect some this in-queries information. And this is the result. The result is shocked. Nearly the 40% are hit. Nearly the 40% are hit. So maybe my name, maybe my file name is easy to let the user to click this, such as the PUBG map hacker and the girl, whatever. And this is a simple demo, just the attacker and Vincent. You can see we create the documentation, and this is hidden the mass file and hiding it, just one single documentation file, and pack the whole directory and send a mail to your target. Send the mail, and the target check the mailbox. He got a file. He read the email, and he find there's a attachment, and download the attachment. Attachment is the IP. Okay, unpack it. Unpack it. And go to the directory. This is the documentation. And this is a simple demo in real attack. Maybe the others we hit. Maybe just do this. And in this research, we get some result. The macro phishing is just 11% to 14% success, and the DDE phishing is nearly to the 30%, but the VSTO phishing with hidden nearly to the 40%. So expect the phishing. What can we learn more from the VSTO attack? The VSTO loading is, as I said, the first step. The office will check the registry, and then the application will load the DEL. The DEL is load the other DEL, and the other DEL will load the add-ins or the template or the extension to execute the code or your command you want. And then the Office application will check the will do some security check. Just for example, the documentation is legal or illegal, and so on. This is the whole VSTO loading process. From this, we can see VSTO, the whole process, is also include the CLR CLR execution. So the CLR attacking surface is worked on this surface. So since the VSTO documentation were hosted by the CLR, so we can do the same things in CLR, and we can do the same thing in the VSTO. So there's a question. Can we find more bugs from this idea? The answer is yes. We create a mod, we create a fuzzy model, and the ideas is first. .NET framework include CLR and C# code will translate by CLR, and we can just fuzz the IL code by the MS-IL injection easier, and we control the IL code, and then we control the .NET application program flow. We just need to control the IL code, and we just can control the program. We can control the application, and this is our fuzz mode. In this situation, in this fuzzing situation, the MSIL injection plan B, just proposed by the Frag magazine, is better. So we do some fuzzing test, and there is a simple code which we can invoke our defined code. This is just like a template. Oh. This part refers to the Frag paper, and I just need to fuzz the DEL or fuzz the IL code. So let's see. For example, we choose the peach fuzzy to do this work. I wrote a peach fuzzing template to in this following image. You can see I just change the DEL or change the IL code, and this is run result with the peach. And lucky, we just do this work one day, and we got the Office crash. And we also locate the reason. It is a logic bug. It is a logic bug when Office search when Office opening and search the target and search the tag in the registry. I consider it's not a low-hanging fruit exploit, but I have not submit this report to the Microsoft, so I can't see this clearly here. And sorry guys, let you hear our rubbish spoken English. This is my acknowledgement. The first we will thanks to the Frog magazine author, Anthony, and I will also thanks my boss, YG07, and the last the killing team is our some underground hacker, and this is a link for the Fracker magazine. Okay. Questions?
All right. Before we adjourn to the break for your lunch, which everyone is eagerly to go for, any questions for the gentlemen over here? I will be the translator, so don't worry. I will try to translate what you means to him, what you want to say to you. Any questions? All right. Thank you very much.